Yes, we are live now. I welcome Anirudh Kaul to this wonderful session on edge computing. He is an AI expert and UN and a TED speaker, author of Orally and a practical deep learning book. A former scientist at Microsoft Research, where he founded Seeing AI, considered the most used technology among the blind communities. After the iPhone, he works on the Pinterest, helping include emerging technologies. With these features shipped to the billion users, he brings a decade of product oriented applied research experience on petabyte scale datasets. He has also been working on other technologies. He serves as an ML lead in NASA AI Accelerator Frontier Development Lab and coaches and learns robot races. The Formula One Championship of autonomous driving at 200 miles per hour. His work is AI for God is something which IEEE has called the life changing. Has received award from CES, ECC, MIT, Cannes Lions, American Council of Blind, showcased at the event by UN, World Economics Forum. While White House, House of Lords, Netflix, National Geographic, and landed by the world leaders, including the Justin Trudeau and the Theresa May. It gives me an immense pleasure to have Anirudh Kaul in this session because there is a lot of things going on behind the hood of what its technology has to give. So it gives me immense pleasure to call Anirudh Kaul, sir, for giving this wonderful session on edge computing. And thanks for accepting the invitation at a very short notice, sir.
Yeah, I appreciate the invitation. I'm just watching your excitement about the session. It's giving me more energy now. Uh, I'm thankful to people who are always looking for learning. What are things happening beyond their own comfortable zone, especially in the field of AI? And hopefully, today's session, I try to stay a little bit away from theory because understanding every math equation takes me more time than I would have assumed. So today, what I said is, you know what, let's do whatever we'll do today will be very, very practical. It will be very about how you on your own journey could do certain things, right, in the area of edge and especially on mobile deep learning. Now, before we get there, in life, you can't really
Sir,
achieve.
also one thing, a shout out to APSIT and CIT people who are live streaming on their screen now.
Hey, appreciate joining today. I hear
Yeah,
many of you are here.
yeah. APSIT and the CIT folks who are looking live on their screen. So yeah, shout out to them. Thanks for live streaming on the big screen actually.
The
Yeah.
Yeah, I think it's a Saturday morning, so I don't know what else to say. Then thank you for joining on that. Uh,
Yes.
so I think like talking about morning, what's the motivation to wake up? What's the motivation to even be in this lecture? I think we need something to get us started on the high note. So I thought one of my friends could give some motivation of what you can do if you knew deep learning on mobile.
I'm Emily.
How
This is Bloomberg Technology from San Francisco. In a moment, we'll be talking to Techonomy CEO David Kirkpatrick about the social media phenomenon sweeping the vegan meat industry. But first, we have seafood founder and CEO Jin Yang. Sorry, Mr. Yang?
It's a Mr. Jin Yang.
Okay. Mr. Jin Yang, you just sold your company Seafood to Periscope, and we're hearing the deal closed at over 15 million. Can you confirm?
I am a very rich.
My sources at Periscope tell me the tech is quite impressive, and your app uses the same machine learning to recognize if a food is a hot dog
And a not hot dog. It's very important. It's a hot dog, not hot dog. It's technology.
Excited to see it in the App Store. I'm told it's releasing today.
For free because I'm rich.
So, I mean, this was just tongue in cheek, but the real motivation for today is that what if you had a bright new idea? What if you had a bright new idea for a Snapchat filter or for a mobile phone app or something on the edge side of things that could make you into a millionaire like Jin Yang? So, going over our presentation today, we'll see a couple of techniques a couple of platforms, a couple of great apps that we can get inspiration from, and along the way, see what we can learn. Hi, my name is Anirudh Kaul. I don't think I need to say anything after that amazing introduction. I hope my mom is watching. Have been doing a few fun things. One of the real fun things recently is this thing called the Robo Race car. It's basically an autonomous car that you race with your AI agent trained on reinforcement learning, and then put it on a real racetrack. This car is like a couple of $1 million. So if you crash, I think that's going to be a bad day. But our team of students went in there, and we ended up on podium on our first try. So that was exciting. And the funny thing was uh, while writing my book, this was the last chapter of the book was about autonomous cars and how somebody can recreate them. And the last page was the photograph of Robo Race, and that just ended up happening. So now that we have woken up, have seen some excitement, so I think we can go towards why deep learning on mobile. And there could be many, many reasons. One being privacy. The world is moving towards a very private, in a very private manner, where the data of customers cannot always be shared on servers for a company. So that's one big thing. Keeping data on the device is great for privacy, and customers like that message. Reliability. What if something happens in the network that the servers are not available? If it's on your device, the availability remains there technically all the time. So reliability is great. The cost equation also comes in. When you start to scale things, your server costs also start to horizontally increase. But if you could do the processing on the mobile device of the user, then obviously the cost equation reduces by a lot. But I think if there were any big reason to do that, it would probably be latency. Latency can enable you to build user experiences where they are fluid if it's low. But if you have to go to the cloud, that's already like 2 to 3 seconds of delay. So latency is an expensive thing. For example, Amazon did a study, and they found that for every 100 millisecond increase in latency on Amazon.com led to a 1% loss. Now, considering the fact that Amazon made $280 billion in 2019, 1% is a big amount. Yeah, you don't want that. So latency can be an expensive thing. Similarly, Google did a study about a decade back, and they found that increasing the load time by 3 seconds leads to about 53% increase in bounce rate. And that's a number you don't want. So we want latency to be as low as possible, keep the user in that interactive, in that interactivity. And especially we live in a world of, where our attention span is as bad as a squirrel. So we want to adhere to making things fast. So there's in user studies, there's this thing called the powers of 10. Okay. The power of 10 is essentially telling you what is the timing in seconds you need to achieve to give the user an impression of certain aspects. For example, if you're able to get it under 1/10 of a second, it's a seamless user experience. Most users won't notice issues under 0.1 seconds. If it is 1 second, it at least leads to an uninterrupted flow of thought. And if it is in 10 seconds, that's the limit of attention. For example, if I open my website on a mobile phone and it doesn't open in 10 seconds, I've probably already forgotten which website I opened, right? But if this is a Snapchat filter, it needs to be under 0.1 seconds for the latency to really work. If I'm typing on the keyboard, it really needs to be under a second of, auto suggestion for it to be an uninterrupted flow of thought. So taking all these sort of motivations, what we need to build a deep learning app is, we have a recipe going on essentially, like anything we build. We need a high quality data set to train from. We need a hardware, which probably is your mobile phone on your desk. We need an efficient mobile inference engine. This will probably be the platform that's running your mobile phone app. And then finally, we need an efficient model. so that you're not giving it a ginormous half gigabyte big model. We want something which is small, light, takes less floating point operations. And if you combine these four things, I think we get a deep learning app. So it's a great way to attack this problem step by step. So what I thought was like, how about instead of like giving a lecture, let me actually ask questions that a practitioner would ask, taking their first feet into this area, and as they work through it, get some answers to it. So the first question would be like, how do I train my model? Many of you might know, but it's actually pretty easy. And the idea essentially is called fine tuning or transfer learning. First, you assemble a data set, you find a pre-trained model which is trained on something very similar to what you're using. If you're training a classifier to learn Coke versus not Coke, garbage versus recycle, you can use a ImageNet pre-trained model. Then you fine-tune the pre-trained model on your particular problem. So you have hopefully labeled your data set and then fine-tuned on your problem. And then finally, you run using an existing framework for inference. The key thing here is the message of don't be a hero. We always want to borrow a model that's already pre-trained on something similar and then go, because it's going to take you so many more cycles if you're training a big model from scratch. Now, luckily, we live in 2021, where a lot of the work has been abstracted and is available in easy tools. So one tool I really recommend is customvision.ai. So especially if you're building an object detector, if you're building an object classifier, customvision.ai is basically an interface where you can upload images, use your mouse to label them, and then or like drag and drop like full folders of things into that interface and press the train button, and then you have an API ready as well as you have mobile models readily available. The point is that this whole process from start to end is under, I would say, 3 to 5 minutes to build a model. So without having to go to Keras and code something, that's like makes it really, really easy to use. The other tip I have for you is that if you want to collect a number of images from the internet to make your thing, you can use this FatCon browser extension, which essentially you go to like a search engine and then you open the FatCon browser extension and it will enable you to download those images in bulk right up there. So just make sure you're downloading Creative Commons photographs, but that's one tip. There's another tool recently launched. It's called lobe.ai, LOBE.ai. And I love that tool for the kind of quality it can get on some pretty hard data sets. I was recently training a satellite imagery data set, and lobe.ai is basically a GUI on your computer and makes things really easy. So this is an example of some, customvision.ai, where I uploaded a bunch of dog photographs. I selected that, hey, this is just a general classifier, but I could also select like a compact mobile classifier, and I pressed the train button, and it literally had already given me all these classifications in a pretty high precision manner. So that was pretty impressive. We did some tests on comparing many cloud services. We compared customvision.ai with Google Cloud, Google Cloud Vision, Baidu, and a few other services. And one surprising fact we found was that 15 seconds on training using this did better than 1 hour of training on the Google Cloud AutoML service. So we have some open source benchmarks out there on that. So just letting you know. The next question would be, how do I run my model, right? How do I run my model? Well, for that, you need a framework to essentially run on. And so it all depends on what kind of an app you're making. If you are building in the Apple ecosystem, you'll use CoreML. If you are in the Android ecosystem, you're going to use TF Lite, TensorFlow Lite. And if you are in the Android, Apple, both ecosystems, it could also be MLKit, which we'll get into it. I made a mistake. I meant to say you can do both Apple and Android using TF Lite. I think that's what I meant to say, as well as with MLKit. So the TF Lite and MLKit options allow you to go both sides of the equation. So let's see a couple of them. So Apple's ecosystem essentially started with metal back in 2014. So when we say the word bare metal, it's essentially how fast can you run something. So for video game programmers, Apple had built the metal platform to enable GPU augmented operations, GPU accelerated operations. But when deep learning started to take off, before that, you had to really go and build the convolutional operator yourself. Uh, so in 2016, Apple said, you know what we'll do with? We'll actually give you the word convolution as an operation. We'll give you the word ReLU as an operation, and you can join all these together and build your entire model and then run it on a Apple iPhone. And that was like great story. Uh, the Hello World application for that, right? Like the basic ImageNet running program for that was 3,000 lines of code because you had to actually join each and every operator and end up building that. Like that's how it used to be done. So in 2017, Apple said, okay, hold on. I think we can make things a little easier. So since then, essentially what you do is you go to Keras, you have your model ready, and then you convert it into Core ML, and then you just drag and drop it into your app and it runs, literally. So it goes to the level that they want to make things easy. They want to abstract away the amount of deep learning knowledge you need to know to get things done. And that's what Core ML enables you to do. So when Core ML originally came, it essentially was like you drag and drop your Core ML model into the app, you call that model, and you do the prediction, and that's great. And then from that point onwards, things would start get more and more optimized year by year. For example, they realized that, let's say I'm building a mobile phone app. So I will put, let's say, ResNet 50 model, which is about 98 to 100 MB. You are going to do that same. So that's another 100 MB. Then Tarun is going to do the same, and that's another 100 MB. And imagine a user is downloading all three of our apps, then suddenly we have like 3 apps, each of 100 MB each. And majority of that network, that ResNet 50 backbone, was actually the same in all three of us. So Apple said, you know what, hold on, let's do something better. So they shipped the ResNet model as like inside the operating system. So we don't have to download it again and again. And then what we as developers could do is we can just share the final few layers in our app. So our models become really tiny. So from that 100 MB, we actually got down to say about 50 KB, 500 KB, or maybe 1 MB. In fact, since then, even your language models like BERT, they are available as part of the Apple ecosystem. It provided other facilities like quantization. Most of the models that you save are 32 bits. Imagine if you could go down to 16 bits, that would be half the size of the model. If you can go down to 8 bits, that's half the size of the model. So Apple provided all those facilities. Actually, it's one line only, so just it's easy. Batch support for improved performance. So imagine you had to run through an entire, like literally all the photographs on their mobile phone. You can do it in a batch manner, and it's actually much more energy efficient. And few more things. Eventually, TensorFlow also had a port to enable conversion from TensorFlow to Core ML called TF Core ML. And then eventually other things started to come. For example, on-device training. So when you are sleeping, your phone is connected. It can actually, that's how Siri pretty much trains itself every night when it's being charged. So you can do that. You can do personalization. And more importantly, there's a tool that came out called Create ML, which is a GUI tool for training some of these models. So in summary, life is just getting easier step by step. Here's an example of a benchmark on Core ML. And one thing I want to notice here is what happens when the operating system changed. So it's exactly the same model. There's a Boston-based startup called Fritz, and they did a study, and they found that as they went from iOS 11 to iOS 12, the model actually got faster. Uh, so it's the opposite of what you had imagined, right? You usually imagine that things get slower, but the within the OS itself, it actually made things even more faster. So that was nice. The other interesting thing is, let's look at this graph. So me and my co-authors started to benchmark this and found that if you look at this left graph here, this is from 2013. Then is 2014 phones, that's iPhone 6. Then 6S 2015. You notice that something happened between 2014 and 2015 that just dropped by a bunch. You know what happened? Phones started to ship with something called as a GPU. Yeah, it's a tiny, small GPU, not that much powerful, but even a little bit amount of GPU on your mobile phone actually leads to drastic improvement in the AI performance and speed. So, and this is actually an important figure because I'll come to this slightly later. But when you release an app in the market, you want to support the last 4 years of phones. What that means is that the worst case performance that you want to deliver to your user should still be should the phone which is 4 years back should still be real time enough for it to run. So that's one way of thinking about it. So I think the good news I want to maybe say is that if you look at gigantic models like ResNet 50, they are taking 20 milliseconds on an iPhone 11 Pro, right? So, but even if you go 4 years back, they are taking 77 seconds. It's less than that zero point 0.1 second figure I was giving. And essentially in 2021, if you release a model, even if it is gigantic enough, I think most phones are powerful enough to run it. That's the TLDR summary you should take from that. Awesome. So we saw the Apple ecosystem. The one problem there is when you make an Apple ecosystem model, you get stuck in the Apple ecosystem model. So you can't go to the TensorFlow land. So let's look at what was happening in the TensorFlow side of things. So I think November 2015, TensorFlow came out. Great, gigantic piece of software. So in 2016, Pete Warden and his team started to take TensorFlow and remove things away from it to basically make TensorFlow mobile. And TensorFlow Mobile was basically 1.5 MB in runtime size that you could embed into your mobile phone. That's like pretty small. But it is essentially a port of TensorFlow, right? So then in 2018, they said, you know what, let's start a ground up effort to rebuild TensorFlow, but only for like mobile and edge scenarios. Maybe you want to run things on the Raspberry Pi, maybe you want to run things on low power devices. So let's reimagine that. And they came up with TensorFlow Lite. And just for comparison, when TensorFlow Mobile came out, that was 1.5 MB in size. When TensorFlow Lite came out, it was only 300 KB for the core interpreter and the supported operations. So you can imagine that 300 KB is what you would have to include as a library in the app you're shipping. So things remain light, so that's kind of good news. The other part is that it is fast. It takes advantage of any on-device hardware acceleration available. That's good. It makes use of flat buffers, which essentially reduce the footprint used while building your app. So fun story, flat buffers actually came from the video game industry. When you look at those video games where you have I think they call it strategy games, and you have to go over a humongous map. Loading those maps takes a long time if it is all really, really serial. So for that, flat buffers were invented primarily to make those video games, easy to load in memory. And well, they made their way into the AI world now, and we all use it to improve our startup time. Also, the key point is that we want to reduce the CPU cycles on serialization and deserialization, and that's another thing that it enables. The other thing is that a lot of deep learning is essentially mathematical operations. So one operation is, let's say, this convolutional operation, and the next operation is, let's say, the ReLU operation, or like batch normalization. But if you're multiplying A and then you're then multiplying whatever the output is with B, you could actually multiply both of them together, and that's what they call prefused activations. And this makes things even faster. combining things. And then you can also do static memory and static execution plan, so that instead of at load time doing things dynamically, you have already decided and encoded it, so it decreases the load time. Now, it's smaller, it's faster, it has minimal dependencies, and it allows for running custom operators. So, in a sense, it makes life really easy because, and let's go over this is entirely the line that you need. So, if you train a model with Keras, this is all you write to convert this into a TF Lite model. It's like a one-liner. By the way, you'll keep hearing me through this entire presentation. One-liner, 5 minutes, that's all the effort needed. And once you have done that, then you can take this TF Lite model and shove it inside both an iOS app and an Android app. So you have to obviously put the TF Lite, TensorFlow Lite library in the app you're building and this model. And hopefully this model is small enough that you can build your crazy dream. So I think this is the way to go if you want to build like a dual sort of an app. So life is good so far, right? Seems to be doable. Now, maybe if things could be even more easier. So for all the good praise I'm talking about, TensorFlow Lite, it's still some work to get stuff done, to understand how to do them. And abstractions are always much, much more helpful. So that's where MLKit comes in. MLKit is from Google, just like TensorFlow. It's easy to use. That's what the main modus operandi there is. It's an abstraction over TensorFlow Lite. So now you can bring your TensorFlow Lite model, put it in, and it will just start running your model relatively easily. But here's the kicker. It's really the built-in APIs for AI that make your life even more easier. So imagine you wanted to do image classification, it's built in already. If you wanted to do handwriting text recognition, let's say if you're building like a notes reading app, it's built in there. If you wanted to do pose recognition for the human body, it's already built in. Face detection, barcode scanning, translation, even the smart reply that you want to do on an Android watch, or Gmail, it's built in there. So why won't you use that? Now, here are other cool things why you want to use that. Model management. So you might have heard of the term A/B testing. So when in industry somebody is, let's say, releasing a website, the question is, what if I make a tiny change and that tiny change is better? So you have, I think, probability 101, statistics 101, where you have a hypothesis that something is better. So you essentially try to find make a hypothesis, make a null hypothesis, and eventually decide based on statistical significance. In a very similar way, people do that with websites, right? That's what A/B testing is. But now we can bring AI and A/B testing together with model management. So imagine I train a model. Let's say I'm trying to build a robot, and let's say it's garbage or it's recycle, right? Let's say I'm building that, and I train a model. That's great. What if I have a new model and I'm trying to know that is it actually better than the previous one, right? So what I could do is I could give some users the older model and some users the newer model, and then see statistics on, let's say, dissatisfaction rate, or like the time it's taking for it to run on mobile. Maybe like the new model is heavier and that can't actually be shipped to everybody else. Now, orchestrating all that is a lot of programming that you don't want to do. So what you do is you essentially take your model, drag and drop onto the Firebase website, and it will literally send it across to all your users. And it gives you the option to read their metrics, so you can know that is this model even working well or not, as well as you can see the statistics in different countries, how much latency did it take, and other things in there. So it makes, if you want to be a professional, I think this would be like the easiest way to ship things without having to go through enough pain in developing model. Awesome. So, hey, I should have showed you this before instead of saying that this is easy. This is literally easy, right? So this is calling a vision API for a face detector, sending it an image and getting the output. So it took 4 lines, essentially. Can't beat that, right? So that's great. Next question would be, so let's think through a couple of questions. Your question might be, How do I keep my IP safe? Imagine you go and train a model which you think is gonna be multi-million dollar worth, and you don't want to just let any person be able to download it. You want to obfuscate it, right? So when we write code in, let's say, C, right, and we compile it, it's kind of already obfuscated, so you can't do much with that because you don't get source code, you get the executable. But here it's a model at the end, which can pretty much easily be opened up and downloaded and used by anybody else. How to prevent that? So there's a startup I mentioned from Boston. It's called Fritz, and Fritz makes a really easy platform for non-mobile developers to become mobile developers. So you could be a data scientist, you can be somebody working in Keras and not knowing much about mobile, but it provides you this entire platform to deploy your models on an app. They have an open source app called Heartbeat, and you can see your model running on top of that. But more importantly, as you start getting more and more professional, they have mobile specific models which are light enough, but then you can do the analytics, that you can do the monitoring, you can do the model management. So you could keep like 10 models and see how users behave with all 10 of them to decide which one should be your production model. And you can also do model protection, which is essentially obfuscation. I think the key thing that you should see from a professional's point of view is that it's not just about running a model, it's the story beyond. It's the story of how this model is managed in a production environment with good software methodologies. And you don't want to do it yourself. You want to reuse as much as things are available. So MLKit would be like a good startup. It's totally free to start using it, and Fritz would be the next one. All right. So now that we know the platform to run things, Core ML, TF Lite, MLKit, now comes the question, and how to obfuscate it. Now comes the question of, does my model make me look fat? Which basically is the question of, in iPhone at least, you cannot download a 200 MB app if you're not on Wi-Fi. So it only allows you to download it if you're on Wi-Fi, because if you're on the street, I think we'll eat up so much of your bandwidth. They just don't allow you to download. And that means that your potential app, somebody might be on the road and cannot download it, and that opportunity to get your app downloaded is over. So you want to make your apps as small as possible. And one of the ways of doing it is that instead of putting the model inside the app, what if you actually keep the model on a server, let the user just download an app without any models, and when the user is onboarding your app, it gives the user the option of downloading the models at that point. So if you have looked at Google Translate, Microsoft Translate, it has 50 languages that they can translate, but they don't download the models right away. It's like a small app. You purposefully say that, hey, download the app, download the model for, let's say, Hindi, for Russian, and only then it downloads, and then it'll download like a 40, 50 MB model. So that's one of the strategies to combat it. All right, I think we'll love more edge stories. So the question is, what effect does hardware have on performance? Very important question. So here's an image from about 2 years back. So this is Google Pixel 3, and this was essentially the Geekbench score that you can do on devices. So Google Pixel was getting a performance of 8,000. MacBook Air was getting a performance of 7,000. And iPhone 11 Pro was getting a performance, and it was beating a laptop. I think that's the key thing to realize. Phones have become so powerful now that they are starting to beat laptops, and that's just crazy. Right? And that's good news for you, because if you don't even care about optimizing mobile to the nth degree, your app will still run. So that's good news. But let me make it even better. So a few months back, iPhone 12 released with the A4 processor. It has 11, it's almost 12 billion transistors. It can do 11 trillion operations per second. It's so fast. It actually has a 16 core essentially a GPU inside only for AI and nothing else. That's not even counting the CPU and other dedicated processors on it. So uh, things have become really, really fast. Things which you would not have imagined 3 years back. I mean, that we can say about any technology, but especially in the mobile side of things, it has actually just gone way beyond. Here's an example of an iPhone XS on the left, X in the middle, and iPhone 5 on the right hand side doing background segmentation on a video. And you can see how the different generations of phone go from real time on the left hand side to totally patchy and blocky. So that's the kind of quality you can get with different years. If you are deciding to build your own app, or let's say you're building a smart glass and you want to put AI on the smart glass, you want to see, like, will this model even run? So there's a website, aibenchmark.com. You can go to that, and you can see they have run benchmarks by crowdsourcing uh, a number of mobile models on different mobile phone apps. So let's say you were wanting to build a smart glass. You could go to the market and see for that smart glass which is the chip inside that smart glass, and then you go to this particular website and start seeing these chips. And let's say it was Snapdragon 845. You can then go on this and see essentially how many milliseconds does it take for specific tests. Some tests are about face recognition, some tests are about a ResNet 50 model, and based on that millisecond, you can decide that will it be real time or not. So that should give you a good idea. Uh, I believe not everybody will have like the whatever is the state of art model, like the Huawei P20 Pro. But that's a good way to understand, will your model even run? The other thing you can go and do is go to Alchemy, again by that Fritz. Uh, in Alchemy, the cool thing is that it attaches with your Keras model, and you essentially take a Keras model and write benchmark. What it will do is it will try to tell you the floating point operations per second in your model, right? Because we want to make things real time. And it will then tell you on an iPhone how much time will it take to run effectively in milliseconds. So it's sort of simulating it, not on your computer, but on the production device that it will be deployed to. So this makes life really easy. What I love about this is that as a data scientist with little mobile skills, I could write a command line and deploy it to my entire million users with just a single command line and manage everything on the command line. So this makes life really easy. So check this out, fritz.ai. Alrighty. Another question would be, which devices should I support? And it's a really important question. I sadly gave you the answer. So my authors did a study on this and found that the golden rule is that to get 95% device coverage, you should support phones in the last 4 years. So that's because I think the phones will basically be replaced in those 4 years, so you can get a decent 95% coverage. And here's the important part. If you run something on this year's phone, this will be amazing, bazinga fast, right? The year before will be slightly slower, but if your model, the hardware is powerful enough, it will still be real time. 3 years back, it's getting in the borderline territory. 4 years, it's probably close to borderline. The point is that if the phone, which is 3 and 4 years back, cannot be real time, and your experience is dependent on being real time, you need to offer some sort of graceful degradation. So instead of giving a really bad user experience, maybe a better idea is not give the experience at all, uh, and tell the user, it's not supported here. Or you could offer cloud-based inference. So instead of giving a choppy experience, instead giving like running, only for one image, but based on the cloud. So on an API. So that's another option available. But you want to, when you run something, I think most developers just look at their own mobile phone without realizing that there are other phones to support. Awesome. This is an important question. Could all of this result in heavy energy usage? Oh, yeah, for sure. Uh, I'm not going to tell you which app this is, and quite possibly you have used this app. But the easiest way to get go from a good rating to a bad rating is essentially to release an app which uses too much battery. 10 years back, uh, if you ask many of your teachers about the mobile phones, they would say that GPS were so bad that it will burn up the battery like in a matter of minutes. Right now, I think GPS is like all easy to use. I think AI has had the same story about maybe 4 years back, and it's starting to get in much and much better. So you don't want to burn the battery as much. Now, here's the reality of things. If you run your AI model at every frame, it's using as much energy as possible. And if you keep running that, that's a bad idea. So we did some benchmarks and found that on a modern um, phone, if you run a mobile net network at 30 frames per second, a modern phone can still run for 3 hours, and that's pretty nice. So a modern phone can still take 2 to 3 hours to burn through its battery, even with that maximal usage. So that should be good news to you. But you don't want that. In a real app, you probably want to run a few frames depending on what the experience is. So you could run something at 30 frames per second. The question is, do you really want to run at 30 frames per second, or could you be done with like maybe 1 frame a second, right? Here's a study we did where we took 3 different models, okay, and tried to run it at different frames per second and then saw the GPU utilization. Notice what happens with this ResNet model. This ResNet model at 20 frames per second is using really high GPU utilization, close to like 50 percent. But when we started to reduce the frame rate as we went to 10 frames per second, frames per second, and 1 frame per second, it came down to like 10% GPU utilization. Same case with even SqueezeNet and MobileNet. Like they started to get really light. The point I'm trying to drive is that in case from here to there, if I was running this at 1 frame per second, I think my battery would have lasted about, I want to say like 6x longer, right? So depending on your use case, decide. And this is important because if it's less energy used, your mobile phone would also heat up less. And this is really important. So let's say you're working with Airtel, or you're working with AT&T, we are working with T-Mobile, Idea, uh, and you make a deal with them and say, you know what, boss, can you ship my app on your phone as a default option, right? And we'll make a deal. You give me some cut of it, and they'll say, okay. If you go to a major mobile provider, what they will do is they will take a heat gun, okay, and then they will point it towards your phone and let your app run. And if your app makes the phone get hot, your app is not shipping. No way on a network like T-Mobile or AT&T. Okay, so that is another reason why you want to be very thorough on making sure that you do not ship something which makes your phone hot. And one of the quick tips is essentially reduce the frame rate. Right? Everybody is happy. You are happy. T-Mobile is happy. Users are happy. Sounds good. All right. So I think we saw a bunch of techniques from a really practical point of view, but I think we need to get back to ground reality. Could we see a couple of applications that maybe would just excite us in how these applications can be built? So let's see some real apps this time, and stop talking and blabbering about. So here's an app called AR Hand Puppets. Really cool, right? This app, I think, was called Yo Puppet, and now it's called AR Hand Puppets by Hart Woolvery from 2020 CV. So essentially, behind the scenes, what's happening is it's doing object detection. So you see that big circle, that's really the object detection. Then within that circle, it takes the image and does key point estimation for the finger joints. Okay, so instead of doing a key point estimation for the body, it's doing it for the fingers. And now, based on that, he has put a puppet which is just being modeled in Unity, right? And that's what creativity happens. Like, user doesn't see this part; they just see the front end part. Now, here's the cool thing. Hart is like a single person army. He built this and he sent a mail to Mark Cuban, the guy from Shark Tank, the billionaire, and said, "Hey, I have made something cool. Would you like to fund me?" Mark Cuban said yes, and they are now partners in business. Cool story. So that's what you can do. Here's another example of an app called Homecode AI. So the app is essentially counting the number of hoops you are able to make. Really cool, right? So what it's doing behind the scenes is as follows. It's doing object detection. It's doing object detection on the player, on the ball, and on the hoop. Then on the player, it's doing body pose estimation to know how the joints are moving. And it's also doing perspective transformation. So that quote you are seeing, right? It's taking that image and converting it into a 2D map of the thing. So then when you finish the game, you can see from what points did you make those shots. You see this point? Like it knows exactly where you're making those shots and give you that. It's so cool. It ended up, being getting viral, being on Apple's stage during CoreML, and yeah, that was nice. Here's another example of magic Sudoku. So we like solving Sudoku. Let's see if AI can make this easy for us. Nice. It's kind of like magic. And it's actually really simple behind the scenes. So what was happening behind the scenes was, as this app is moving, uh, it's first using edge detection to figure out that there is something like a rectangle, like a square-looking object. So that's using edge detection API, which is built inside Apple iOS. Then it's doing MNIST based letter hand digit training to do classification of all these numbers. Like that's like the hello world problem, MNIST training an MNIST classifier. And then it's using ARKit to learn the plane and put that image that it generates on that plane. So it looks magical, but if you think from how you would build it, it's pretty fun. This is AR Pianist. So what's happening behind the scenes is it's not pre-programmed. What this app is doing is it's listening to music, or it's listening to, or like you can feed it a piano sheet, and based on that, it figures out on a piano which keys would that mean, and then it starts to do a couple of things. So first of all, using ARKit, it's able to understand the piano in front of you and localize it as you're moving. Then it's doing object pose estimation, multi-pitch recognition, motion synthesis. So essentially, this thing you are seeing here is an avatar. And so this avatar is being placed around the area where the keys are being placed, which is by ARKit. And then based on where on the piano keyboard the keys need to be, it's being placed dynamically. So it makes life really easy. I think one cool thing I just realized by the time I was showing all this was that most of these apps were built by like 2 or 3 people initially till they became bigger. So here's another really good example of AR cut and paste. I mean, this is just wow stuff, right? Now, behind the scenes, it's actually relatively obvious once you figure out like the individual components. So it's essentially using a Photoshop filter in the initial days, and now it's a pure segmentation filter. Uh, so Photoshop is the app that the person had opened there. Uh, and then it's taking a photograph, doing segmentation over the object that it just took, and then using open sift, sift from OpenCV, it's able to take an image from the mobile phone here, take the actual image from the laptop, and join the location of where this thing is being posted, and just put that image back. So again, it's a one person operation. So pretty cool. This is something from NVIDIA. And so what NVIDIA worked on was, can you convey the a nice video, but at almost 100th the bandwidth? And this is actually using GANs. So what it's using behind the scenes is it's taking an image. From that image, it's generating a keyframe and sending that full image to the user. Then from this image, it's extracting the key points, right? Instead of the image, it's extracting the key points and then sending those key points to the user. And using a generative adversarial neural network, it's combining it into this particular output. But what essentially ends up happening is the bandwidth reduces by a humongous amount. That's the power of what you can do if you can run things AI in almost real time. So if you look at the left versus right example, reducing the bandwidth manually in image compression programs is a bad idea, but here it's just so super smooth. So that's the value of using AI for your stuff. Very neat. Awesome. So let's go to the next question. Can I make my model even more efficient? Yes, you can, because nothing should stop you from taking efficient models, making efficient models. So one rule I would usually say is if you do anything in AI and you have a bright idea, before you tell it to any other human being, another human soul, go to paperswithcode.com/SOTA, state of the art. So let's say if you had a segmentation problem or you had a detection problem, go to paperswithcode.com/SOTA and then look for object detection and a model in the object detection area. But look for the benchmarks, and quite possibly you might see real-time object detection leaderboard, and you can see that, okay, what is the accuracy and what is the milliseconds it will take to run on a particular device. You can also go to modelzoo.co to see some of these models. So here's one example. All the researchers, back when they are fighting to get on papers in 2013, 14, 15, 16 on ImageNet challenges, they wanted to build the most accurate model, so the highest accuracy. But as they started to do that, the number of parameters of the model just kept increasing more and more and more. Now, we as practitioners actually like to make things lighter. So we want things which are actually both higher in accuracy and have lesser number of parameters, which is this sweet spot. So usually something like MobileNet V2, NASNet Mobile, models of that sort, efficient net, those are usually the things that you want to use. And you can probably find these numbers, and I'm probably outdated, so we just go to papers.bitcode.com/shota and find whatever the latest model is. Now, as we have already always experienced painfully in our life, there are things that we want, but those are not the things that we can always afford. And that's the same case in machine learning. You can get the deep learning to work on like large GPU servers, but you might have a really light mobile phone which cannot afford to run at the same level of computations. So the budget, the floating point budget that you might have might be very low. And what we want to do is essentially convert our model to be able to run at the speed of the Ferrari on a light mobile phone or a resource constrained edge device. And we can do that with a couple of strategies. The most common one being model pruning. So when you train a model, a deep learning model, one of the key things that you will notice is that most of the weights inside a deep learning model, they are between, let's say, usually like -1 to +1, let's say. Most of them are concentrated around 0. So some weights will be like 0.0001, 0.00002, 0.00003, right? And then some of them will be 0.1, 0.2, -1, minus 0.1, -0.2. But many of them will be like having that bell curve near 0. So the bright idea here might be, what if we just make all those weights which are really low 0? Because just think about this. If you multiply something by 0.000001, it's kind of effectively equal to zero, right? It's very tiny. So why don't we just consider all of the zero, and all these connections essentially just can be removed. So that's one way of making your models light. And I know there's a theoretical concept as I'm speaking it, but you can make that happen in literally one line. So what you do is, this is your normal Keras code, right? This is a layer for flattening, adding dense, dropout, dense. All you do is you take this code and make this change 3, 2, 1. So all we did here is for the layer, like dense layer, we put prune.prune. And behind the scenes, it will prune this automatically for you. So that's a great thing to do. Essentially, less code, less talk, and just get the line done with like 2 keywords. So that's a great way of making your models light. And in fact, for dense layers, where 90% of your model's size comes from, if you can do like this thing, this will just reduce your model weight to by a humongous amount. Remember, 90% of your model weights come from these dense layers. So do that, please. Okay, the other thing you can do is model quantization. So if you think about models, usually they are in 32 bits, right? So they are like a big range of things that it can be supported. But imagine if you could make your 32 bits into 16 bits. That would lead to what? That would lead to, well, you need half the size to store. So your bandwidth inside, your bus, you can spend twice the number of data now in that same bandwidth. So you can technically kind of batch it and run it at 2x faster speed, at also 2x the lesser the amount of half the size of the model. So if you go to 8 bits, you can be 4x smaller. If you go to 4 bits, you can be 8x smaller. So I think you can do the math around that. So let's take the case of 8 bits, okay? So 8 bits is about 256 values. So what we can do is, one way of doing this is called quantization, essentially converting 32 bits into 8 bits. So what you do is you take your range, take the minimum value and the maximum value in that range, and now basically chop it off into 256 parts. And then put those parts from -127 to +127. Basically, you're converting things from 32 bits to 8 bits by converting into an int. You're going from floating to int. That makes sense. And then you just stored an extra 2 values of what was the minimum value and maximum value for that layer. And you can always go from this 8 bits back to 32 bits now. I think that's the power you get. Sounds like a great idea. So let's do that. So we experimented on it and found the following. When we quantized it to 16 bits, we are able to reduce the size by 50%. That's great. And when we took a network and saw the reduction in accuracy, because you don't get things for free, right? If you reduce the size of the model, you'll probably introduce some error. We are still able to get almost 100% the accuracy as the original model. So that's kind of good. That's pretty awesome. So then we went to 8 bits. We are able to reduce the size of the model by 75%. By the way, this took like literally one line. And I'll hopefully show you, maybe not, but this is essentially literally one line in whichever framework you use. Whether you use something like Tensorflow's model optimization toolkit, whether you use Core ML, each one of them provides you this. So when we went to 8 bits, we are able to go to 1/4 the size and still get about 88% of the accuracy. We notice that there are other ways of generating these quantizations, including a thing called k-means based clustering. And when we do that, we are able to get 98% of the same result as the original 32-bit floating point model. So I'm telling you, you can go 4x smaller with 1.5% in increase in error. I think that should be the takeaway. Obviously, when we start going to 4 bits, I think you can see how we start getting into the 0% accuracy. So don't do that. But I think 8 bits is a safe place to be at. By the way, when you usually convert a model to your mobile phone, it automatically runs it in 16 bits. So without you doing anything, it's already doing it. This is something that you can do one extra step and be even faster. There are so many research methodologies out there that we can have an entire class on that. So one of the things that we can essentially do is, instead of me keep on speaking about them, like channel pruning, model quantization, filter pruning, weight sharing, automatic mix precision, network distillation, there we can do something else. So this is called Pocket Flow from Tencent Labs. But essentially, this is a free open source GitHub package where you drop in a model. It will take the implementation of a research paper for a particular optimization, run through that. It'll take the next research paper, run through that. And it'll essentially take like these different modules to see which optimizations can be combined to essentially get the best compressed model with the least amount of accuracy reduction. That's one way. I might actually recommend something even better than this. I would say go to TensorFlow Mobile Optimization Toolkit today. So TensorFlow Mobile Optimization Toolkit today, and it has actually made so many improvements in it that I think it would be like a single line to get it running and make your model, edge compliant essentially. All right. So this is good. So we talked all the way from how to run models, how to make them light, uh, and a whole bunch of practicalities. But I think that there's a lingering question behind the scenes. Can I design an even more efficient model architecture than what all the scientists so far have been able to do? And I think we'll have to go to somebody smarter than humans. We might actually have to go to AI itself. So there's a whole world of neural architecture search, or as it's called, auto ML, where AI is able to beat humans at designing AI models. It's like a recursive thing there. So I'm not going to complain if it does my job, but I think it's a threat to my job. So I'm going to make it in a balanced, unhyped way. So neural architecture search, essentially what it does is it's like using reinforcement learning, where you set an objective, and the objective is to get the best accuracy, and you tell it that the building blocks consist of convolutions, batch normalization, ReLU, and combine it in such a way so that my optimization objective, essentially becomes happy is maximized. So the optimization objective is getting the maximum accuracy. So you can do that, and that's how people did that in 2017, 18. And then people realized, what, we actually need to run it on the mobile phone. So let's make a dual objective, and the dual objective is it needs to reduce the time for latency to run on a mobile device, but increase the accuracy. So reduce latency, increase accuracy, and that's how the world started to work. The other cool story behind the scenes is that if you actually read research papers, some researcher one day started to run this on a Pixel 1 mobile phone, and so now all the benchmarks that you see on mobile phones are now dependent on running it on a Pixel phone. So if you want to publish a research paper, you better buy a Pixel 1 phone from Flipkart if you don't have it, because you're not getting your paper published. Okay, so in this particular example, people tried to do auto ML, and we're able to get almost a 35 reduction in the floating point operations than a ResNet 50. That's pretty impressive. So let me actually give to some real numbers. So neural architecture search is a really slow process. It's a really slow process. So the first two lines I'm showing here are basically showing the accuracy for mobile networks, and there's like that 70 to 74% area. Running on a mobile phone, the aim is that can we run within say about 100 milliseconds essentially, and we are kind of doing that. But the mobile NAS network from 2018 used to take 40,000 hours, which is essentially 4 years to get to that number. Let me repeat that. It would take you 4 years of training to be able to train that mobile model, okay, to come up with that best model. So it's slow. Fast forward by 1 year, and now you can train the same network in almost under 4 hours. and get even better accuracy, right? So that's the whole story of how things evolve. So you can train it in 4 hours, get the best accuracy. Why won't you do that, right? And all of this is available on GitHub for training. So just to show behind the scenes what's happening, some of these are not just dependent on coming up with a network, but they are dependent on what hardware you are going to run. Whether you'll run it on a Raspberry Pi, or whether you'll run it on an iPhone, or whether you'll run it on a GPU, right? So as an example here, the same exact code, when the objective was to train it for a GPU, came up with a different definition than it was for a CPU, than it was for efficient mobile phone model. So it's really hardware dependent. I think that's what I want to sell you here, that it depends on your hardware. Now, a couple of more questions, getting closer to the fun stuff here. Can I improve my model without access to the user's data? Well, that's a tricky one. Like, without data, how will you improve it, right? So, well, yeah, you can do that. How? Well, the trick is that you train it on the user's device. And that is the point. The question essentially was that as a developer, could you do something where you don't get the data, but the model gets the data? So what you could do is you could first train a base model, deploy it to all your users, and then when the user is sleeping and charging their phone, in the night it will sneak in and turn the model on for training and make like a couple of batch updates based on the data of the user, kind of like what Siri does. And you can actually do this training on mobile phones now. CoreML has that available. I believe TensorFlow Lite for ages wanted to do that. Hopefully it already has that by now. But even the code for it is not that big. So it's all doable. That's good. That's good. But you didn't get the data, right? What if you actually wanted some level of data, at some level at least? And that's where federated learning comes in. So federated learning is the idea of essentially, instead of giving me one user's data, could you somehow encrypt it in such a way that I could use it for training by using the law of aggregates? And here's how it really runs. So what happens is, a good example of this is the Google keyboard. The Google Assistant or the Google keyboard, they all use federated learning. So what happens is that initially the developer trains a model and trains it on their server. Now, what federated learning allows you to do is, instead of doing those training cycles on the server, could we do the training cycles on the user's devices instead? So what happens is it deploys a model on all the users. On the user's device, based on your data, it will now start to do a little bit of fine-tuning and run a few batches. And then it might have done those batches on maybe, let's say, 1,000 users' phones. It will then propagate the update that happened back to the cloud. So it's not giving me the data, it's giving me the delta in the model. And when you join together that delta between all these devices using the federated learning framework, the server can then essentially bring back the learning on the server and join them together so that it goes to the next epoch. So the difference here is that now, instead of running it all on like the server, it's letting the training on the user's devices, and then the batch update, which is aggregated, is given back to the server. So what would have taken you maybe an hour to train now might actually take you 10 to 20 days, depending on how many users you have, or maybe a month. But if you have enough distribution, I think the power is that you did all this in a very privacy compliant manner. So this is like really, really an up emerging area. So this is one way of having privacy and training at the same time. So as I start to maybe end my talk, I think the whole part about building mobile phone apps, or literally any app for that matter, is that you first go and collect the data, you label the data, you train a model with this labeled data. So that's what usually we think about AI. And that's the part that practitioners have to now think about. Well, first of all, you have to convert that model into something that can be run on a mobile device, like maybe it's core ML, maybe it is a TensorFlow Lite model. Well, then you want to optimize the performance. You're not just going front, you're actually going to optimize the performance. So, okay, you might want to bring in maybe the quantization framework or TensorFlow model optimization toolkit there. Then you want to deploy it. You probably don't want to do it by hand. So you want to use maybe MLKit or Fritz to do that. Then you want to monitor that whatever you shipped was good, bad, did it crash, and all this. So for that, you can use again MLKit to see your analytics. And when you study that, you then realize the opportunity to improve and you go back into that circle. So the whole point is that as a practitioner, have this bigger view that model training is not a matter of import TensorFlow .keras and just running a few lines of code or fast.ai. It's the story beyond that makes you into a practitioner. So, we saw a bunch of things today, by deep learning on mobile, building a model, running a model, and all these different things. It's a mouthful. So I hope, it inspired you in some ways that when you go on your mobile journeys or your learning journeys, you can sort of recall some of the aspects from today and maybe have a better appreciation for uh, the art of building things instead of just the science behind it. And I'm sure that you might have one last question, which is how do I access the slides instantly? Uh, so what you do is you email with the subject wget presentation to practicaldlbook@gmail.com. So wget presentation at practicaldlbook@gmail.com or this particular website, and you'll get a mail back with these slides. So by the way, obviously all the things that we discussed today are covered in the practical deep learning book also, along with some of the apps people have built. So hopefully this was a nice informative session, and I'm looking forward to questions. Thank you.
Yeah, thank you for that amazing session, sir. Because I'll give you one thing, one promise that I can give you. We can't see you in person, and trust me, what we can only see is a screen, our slide, and nothing else. We don't see whether you are seeing our slides. We don't see whether you are engaging with us. So I think probably delivering such a huge talk with no boredom and just giving you the fullest of the fullest knowledge. I think probably I'm very thankful to God today that I met such a person. He is a very sweet person. He is very supportive. If you are very good, if you are very keen in your work, so it gives me an immense pleasure to have him on this platform, and it's actually streamed in my channel. So there can be nothing more prouder to be to have him streamed in my channel. So yeah, and I think probably there are close to around like 15 questions from other side. I think probably in the chat I'll be posting it and I'll be saying it.
We
So
can
yeah,
we can do it right now if that helps.
yep. I think probably awesome autonomous. Oh, okay, people are jacked up about the autonomous car and everything. So yeah, deep races and the translated. I have been working on Carla and AWS Smith and translated to car was okay. Fine. Thank you so much for that, Mayank Bhaskar. I think
Actually, I should give just a quick encouragement. So, how we got to Roborace was I basically set a challenge to students that the dream is Roborace, but to prove that, let's well build something on AWS Deep Racer. So, in the book, essentially, we're building autonomous cars virtually in video games, but then using AWS Deep Racer. And then the challenge I set for them was, can you come like to the top 10 percentile in the world? If you can do that, then let's go to the next step. So they got to top 10 percentile. And then we basically, made connections with RoboRace, and uh, essentially we did some stuff in the summer. And when we went to the real race track, we ended up on podium in our first race. And we are actually open sourcing our entire package so that somebody new does not have to go through the headache of building the whole infrastructure for training a system itself. So it's like a car learns to drive on its own by crashing itself. So it's great that I believe that that he's already started with AWS Deep. Mute.
Newton Sheikh is one of the person who is always fond of the community work and everything, and also he's part of our community, the Computer Architecture Club. So he has asked, like, are the tools which you have said, is it open source? Are these open source tools? The tools
Hi,
which you have said, the computer vision. Hi.
hi Newton. Yeah, most of these tools are pretty much open source. Um, Actually, for me, if I'm speaking here, they kind of have to be open source. Otherwise, I won't talk about usually. Or they might be industrial services, which only charge if you're like doing like all crazy industry level. So I think like for custom vision.ai, I believe that's from Microsoft. Lope.ai, I think most, at least on your computer, it is free. And unless you're like building like a full production kind of thing, it's usually free. I think I want to emphasize one thing that sometimes in life being lazy is a good thing because then you can iterate quickly, try hard, fail fast, and succeed often. Instead of like deciding I'm going to code the whole thing from scratch, taking a month to do something, why don't you just like spend like let's say 30 minutes, build the thing in a browser, see that that thing works, and then you have some proof that yeah, this thing will work. It's a great way to explore, build things, and I'm going to actually sell two or three tools quickly. Runway.ml. Okay, runway.ml. It's a tool for artists to basically take a state of art AI model and run it in the browser and start remixing. So you can put a video feed in and run a like latest segmentation model on, or run a GAN training on. That's like a really good model, and I use it because for training my model, for testing my models how they behave in real time. A lot of people train models, they don't know how it will behave on like a camera imagery when real time images are coming in. So that's good. Lope.ai, I'm in love with that. Customvision.ai, obviously, use AWS, Google, Microsoft, all of them have their own API suite, so use them for that. MLKit is free. Yeah.
Yeah, and there is one more person, Anand Kumar. He was jacked up to come for this webinar. So he's not, he didn't register for this webinar because it was sold out. So yeah, under what circumstances might a practitioner choose to train a model from scratch?
Yeah. So this presentation in certain ways has been evolving over 5 years because I think these, that I was talking about 2014, 15, 16, that's where like my teams had to painfully be doing things and, like scratching head all the time. Uh, Now, as these abstractions have come in, the art is like build your thing to run from end to end as quickly as possible, but then sometimes you need that extra oomph to take your model from like 92 to 90%. It's much easier to go from 0 to 80%. Then maybe you will have incremental improvements, right? From 80 to maybe 85, 85 to 88, 89, right? So I think use all these tools to get to like building your main thing decently well. But then, it kind of helps if you slightly know what an efficient net B1 is, right? Now that won't happen on day one, right? But you can abstract that knowledge till you have something running. And when you start realizing, oh, it's slow, like I was talking a few minutes ago about our host who moves around with Raspberry Pis. Now a Resident 50 is not going to run right away on Raspberry Pi at fast speed. So for you, a much lighter model would be recommended there. But you don't need to do that on day one, essentially. So thanks for asking that, Anand. And hopefully, you know you get to the level of training model for a problem that is needed, which is probably when you're training something for Alexa or for like the wake word detection for microcontroller unit, essentially those models are like 40 kb. 40 kb. Your basic ResNet is not gonna even fit inside that, right? Like 40 kb, 80 kb. So you can get this Spark fun board of about 80 kb to train for that, and I believe TensorFlow microcontroller is out there for that. Yeah.
Yeah, yeah, SparkFun actually gave the complete version for the TensorFlow itself. So It was shown by shown in Tensor, no, Google I/O 2019. Yeah, it was there. So yeah, we saw that. Guys,
So
I might skip some question because there were two colleges which tied up with me for this webinar, which they live streamed on the big screen because students, if you give the phone, of course, they will be chatting something. So yeah, we are supposed to stream on the live screen. So I think I might miss some questions, but yeah, Anand, there is one more question from your side. TensorFlow being lighter and consuming less memory, does this lead to low performance as compared to Apple phone?
good question. Excellent question. Well thought of. Uh, I'm actually going to nod my head for many years because I could see the numbers, but no more. So what the story is that think from Apple's point of view. Okay, Apple wants to get as many developers as possible, right? No matter what, right? If it means forging alliances with Google to do that, why not, right? So what Apple is in the business is that look, we are giving you all these, core ML and all these good things, but we will still give you access to that metal performance shader. So if you are like a geek who wants to go the hard way and have access to as fast as possible, we are going to give you. Google says, thank you. We are actually going to run our TensorFlow Lite using your APIs. So underneath the hood, it's actually using metal performance shaders and other things. Uh, and essentially it runs fast like through like my team's journey, like we got really close to the teams at Apple as well as Google. So like we would go and give demos and ask questions at their headquarters for things, because many of those demos would be like a bit ahead of what is maybe publicly known in industry for things that would be doable. But just learning through how things are done behind the scenes, uh, it's definitely interesting that people want to get developers to get the power to do things. So everybody's friends here in that journey.
Yeah, the other thing, Anand Kumar Ravi says, does the golden rule of offering support to phones manufactured 4 years back vary by Android and iOS, the support? And Apple is better than Android at getting customers to upgrade the OS? Or is it purely an hardware consideration? Is question.
So I'm going to just say the reality. On an Android, I can't even guarantee it will run on the same year's phone, let alone like 4 years back. I mean, it has become better. Uh, Apple, yes, Apple is almost like a guarantee kind of a thing that when you run something on an Apple phone for this year, there is like ability to have some predictable performance and all for phones. It won't break. The fragmentation is not there, right? So that's kind of a good thing. But when you talk about Android, uh, I think the fragmentation has probably been be a plague thing. But I'm not gonna, start weeping right now because that problem has been there for 10 years now. Like, I'm not like telling you something new there, right? Now, the thing to understand here is that Fourier rule that I made up. It's a made up rule, right? It's a rule based on analyzing data of users. It's that how many users are using your app and analyzing it over many apps. And the story being there that it's a rule for developers, not for the support of Android or iOS. So I'm not talking the OS is going to support your app or anything. I'm just saying that usually, if you are releasing an app, you better support 4 years if you want to get 95% of users. If you don't want 95, you want 90%, okay, just support 3 years. It's a law of diminishing returns, essentially. But 3 years, you have to kind of do it. As the phones have started to get more and more expensive, people have started to actually keep the phones more and more longer. And now you need to kind of support those phones. So, great question. Very, very well thought, Anand.
Yeah, let's move on. So, curious to understand the difference in order of magnitude. I think probably, yeah, there is one more question from Anand. So, curious, how does energy, okay, I'll stream it. So, curious, how does energy utilization vary for something like Netflix movies recommendation algorithm, which runs on client side, phones or tablet, to the best of my understanding? Like he has told, it might run on the client side to the best of his understanding. What's your view on that, sir? the energy utilization?
Yeah, so I would believe that would be hard to do because the data that Netflix would need at the end of the day would be somewhere on the servers. I think that's my reasoning there. But so look, different modes need different requirements. Okay, so let's take a quick example. I could be a vision based application. I could have a text based application. I could have a sensor based application that just uses the accelerometer to know that the phone just dropped off or not, right? So that maybe you wanted to build an app like is the person in an accident or had a sudden jolt, maybe for an elderly person, right? Could be LifeLog that can just send an alert to their family if something happened. So you can have data in many ways, and the models for that would also be different. You could have a tiny model even for vision, like the MNIST model, right? Or you could have like a ginormous model like the GPT-3, which takes 1 terabyte of RAM just to load, right? So there's a whole range of things that's available. One thing I will say is more and more of these applications are, let's say Core ML, they already give you some form of an implementation built in these days, so that you just use the UI. It's called Create ML, and you are able to train those models really easily. And the point being, uh, you could have a tiny model depending on your case, or a big one. Let's say a sentiment classification model. The moment you step into the language models, you actually have less. It's not the compute, it's actually the memory you need is much more big. It's the computation is like we can run along with that, but it's really the amount of memory people need for running things. And uh, for recommendation systems, it's actually the amount of like the background database that you need. Now, when I'm reading your question, I think the question was about recommendation system. My guess, if I was reading what you're saying, is it's probably trying to build an interest embedding for the user and just conveying that embedding to a server to get like what recommendations there might be. So embedding might be 128 bits, 2048 uh, bits, bytes, uh, right? 2048 vector, each vector with being of 4 bytes, so that's like 8 KB. But that's like the like everything becomes one thing. When you use Amazon, for example, or anything, it's converting all the product information to some sort of an embedding to do its internal matching. So that's all I can say. No great answer, sadly.
Yeah, Raghavendra Thakur has asked, can you give an complete flowchart of building AI application for mobile with tools for different stages?
Yeah, actually, I can maybe show. So the let me share a
On
screen.
the screen, sir.
Okay, so the book I was talking about, the practical deep learning book, I think it came out of the same story that I had to give these lectures again and again to get engineers to get into AI. So it was like, why don't I just write that part? But one thing that you might find value is in the GitHub part of the book. So the practical deep learning book, and it has the GitHub. So with all the notes, all the images of this is open sourced. So if let's say you wanted to give a lecture in this particular area, you could use those images. So let's say this was the mobile portion. Uh, you could actually see the figures, and essentially some of the things that essentially come for building a full app at the end come pretty close to here. So let's say uh, yeah, so this is like a mobile development lifecycle. I think I'm answering the question correctly now. uh, which is essentially that when you develop something, so the first one was essentially the one you already saw, which was that you collect data, label it, train it, convert it, optimize it, deploy it, monitor it, and then you realize you did totally wrong. So then you basically go again in the circle improving it. But when you do it in reality, what you do is that you get a bunch of friends and give them different rings. So you train a model, you put it in your dev ring. So dev ring would be you and your developers. Test it out, collect data, and then put it back into the data set. Now, then you deploy it into the alpha ring, and this is like your early adopters, like really early adopters. Really your really good friends. Uh, and then you give it to them, let them use it, let them collect some of the bad examples, and then train it with adversarial learning. It keeps getting better. Once it has reached some level, you then give it to beta. Beta could be, you could go to Reddit and like tell people, hey, would you want to use my app? Share it over test flight. And then eventually you want to go to production. The point is that these rings are essentially your circle of trust to go over. So I think in this chapter we build like a food app, like Shazam for food based on a TV show. It's like a real TV show app, and like taking people through this journey in the form of questions and answering that. So that should be. I think maybe one thing that I would maybe just say in your own journeys is. Instead of theory first, like try to find something that is really motivating to you personally and just go build it, because you will learn by building. If you think that you learn by just reading documents, no, you have to build something at the end. So yeah.
Yeah, I think. Sorry, folks. I think I might have missed some questions, but there are some pretty good questions from those people who streamed on live on their screens in the college. So, there one person from AIT is asking what's the influence that an edge computing can have in our real life experience? AR, MR, XR. So, will it really affect us in the tomorrow's real life experiences?
Yeah, I can just give you. So, uh, okay, so a couple of things. So right now, one of the teams I work with essentially is an accelerator for NASA. It's called Frontier Development Labs, and we basically think about where are things that we can run. And well, I think we just had a great example of Mars rover, right? It's an edge device at the end. You don't want to make it burn its energy that it's getting from the precious solar rays on like a heavy GPU operation. So you want it to be pretty power efficient, right? So that's like on a Mars level, like it's kind of far away. Similarly, cases with oceans comes in there. So you need to have that memory footprint. But when you talk about AR, VR, I think that's like a great thing. You want to go to forests and let's say you wanted to count conservation in Kaziranga, right? How many rhinoceros are there, and you want to count that, right? So what would you do? You put those Raspberry Pis with a camera with slight solar chip on it, and just keep pointing it towards to start counting things, right? You need to be energy efficient there. When it comes to the mobile side of things, essentially, I think the mobile phone is where most of the magic is going to go happen. When you talk about augmented reality, uh, it is actually relatively heavy. So you see augmented reality and you see AI, but now in 2021 we are starting to combine them. I'm just going to give a personal story. So one thing, I have been making a bet for several years on a project which is slightly impractical to do because of mobile phones still not being that practical to do, actually became real this year. And that bet was for 5 years that you could pull off. It's essentially video prediction to predict what your mind is going to do in the next 2 seconds by watching what you are doing in the last 2 seconds. And it's not a convolutional network on an image, it's actually a sequence. It's on a video that's being shown to a camera to predict what the person will do in the next 2 seconds. And now you can do it. I literally bought a phone just for that reason, the iPhone 12 Pro. So I think we are in good hands with technology. And the question you should be asking is what you can do, because don't let the big companies think. I think it's really to like individual developers, students to think of that next thing.
Yeah, it's a pretty good question, I think so, because he has asked about the FSD computer and the Waymo hardware. They are coming out with the generations of hardware. So it's all about the self-driving car. FSD computers and Waymo hardware is there, but are there any chances that we can build our own hardware architecture for getting our own neural network built on an hardware? So that's his question.
My problem is I'll say yes to everything because I can see how it's doable, right? Look for this word called binarized neural networks, BNNs. Okay, binarized neural networks are essentially 1 bit. So not 32 bits, not 16 bits, but 1 bit. And the way you get there is using embedded learning library. This is all open source. It's actually for makers. So if you are an electronics student, you can go here, Microsoft ELL. So essentially, it gives you this code on like get your network in, whether it's an audio network or whether it is a image network, and it will binarize it down to 1 bit. Now, the magic of binarizing is that your size goes down by 32x, but your speed might increase by 60x. Okay, so that is like potentially possible. So at in your Raspberry Pi, you might have seen donkey carts, uh, which is essentially open source platform for building your own car. It might have a Raspberry Pi on top of it. Now, donkey cars usually are controlled through a controller somewhere. It's not actually running AI directly, but you can run the AI on that. But if you now start to combine the Raspberry Pi, the latest one that came out, and a binarized neural network and run on it, you'll start beating everybody in the world, right? And like this is all doable. So yeah, you might want to check that out.
Yes, sir. Last question. I think it's time for us to move out of the session so that we don't take too much of your time. So he's asking how to program a new architecture, whether it's whatever you have said about the BNN or anything, CNNs or on the edge computing. So how to program a new architecture?
So almost in any experiment my teams do, they kind of now just keep using a pre-trained network, and I tell them why not just use a tiny network that you build yourself, because you kind of get slightly better at the art of neural surgery and like figuring out okay how many number of layers leads to what kind of results. Like you don't need like something with like 1 billion operations per second if you can get that done in 1 million, right? So I think doing it yourself teaches you things, but then for production, I might just generally recommend that use a pre-trained network, which is just efficient. So that's the value of learning the art of doing it yourself, which only comes when you build the projects. Uh, as we are ending, I might actually want to give a shout out to some. I know many of you might be looking for opportunities for internships and for building that project kind of experience. So there is something that is coming up. It's called Space ML. So it's at spaceml.org. So essentially, what we do at Space ML is we try to find projects like for NASA and see how we can get citizen scientists involved, students who are doing capstone projects involved, uh, you know, uh, on projects that they can then interface with someone like NASA. So we right now are like building an application from them. It has many students from like third, fourth year in India, for example, from Korea, from other places, and we took them through some training. Then we took them through uh, like building that particular application, and actually, I mean, most of them ended up with research papers at the very end and presenting it in front of NASA and solving some problems that hadn't been solved in 7 years. So one of the problems they are, for example, solving is how can you search for images of a particular concept like wildfires, like uh, hurricanes and others on Earth with one problem that they don't have any labeled data. So they give an example of a wildfire and they want all wildfires over the last 20 years on 197 million square miles of Earth. That's essentially about 40 petabytes of data. So it's a team of students, and they have already solved, a whole bunch of problems in that. So that's one example. Another example is trying to have cameras to look on the night sky to figure out if it's a meteor that's gonna come and like make us like dinosaurs. You know what happened to dinosaurs like couple of thousand years back. Will that happen to us? So essentially, they started building that, and we had a student from Nigeria who didn't have electricity at their home, so he would go to cyber cafe to code, and like his website is now actually up on NASA's website. So it's like a cool story of how uh, citizen scientists can impact at things at the NASA level. So I will highly recommend that. Keep lookout of our spaceml.org, spaceml.org, and there will be a call here. So reach out here, and I can connect you with a couple of projects that would be coming out, because we need people who want to learn AI, but then also contribute to a bigger purpose. So that's what I would say. Spaceml.org.
Yes, I think all the doubts were very related, and all those were had like they were all interconnected. So I had to miss a lot of questions which were asked by the students also, and also many of the questions were asked in the chat box. So thank you so much, sir, for this amazing webinar. This webinar wouldn't have been possible without your enthusiasm, without your uh, interest to teach hundreds of the people who are looking at this in the live session. And I think probably
Sure.
it's going to motivate hundreds of people who have been seeing today on the through their colleges. And thanks for those two teachers, Vumala ma'am and also Harshini ma'am, for actually giving me such a wonderful opportunity of streaming this live on their departments. And thank you so much, sir. Thank you.
I appreciate both the teams for streaming it there. Yeah, I hope today's session was fun, and I'm excited to see what all you do in your own journeys and building stuff. If you have any questions, you can reach out at that email address, which I've already forgotten. It's practicaldlbook@gmail.com. So if you have more questions, you can share your questions there, and I look forward to it. Thank you.
Yes, thank you so much, sir. Thank you so much. Bye, people. Thank you so much. And yeah, APSIT, CIT, I'll be meeting you a little later.
Take care, everyone. Bye bye.